Have you ever wondered why a pendulum swings back and forth in such a rhythmic, almost hypnotic manner? Today we dive into the fascinating world of pendulums to unravel the physics behind this captivating movement. Imagine a child on a swing. They kick off and the swing starts to move back and forth. This is the simplest form of a pendulum. A pendulum, in its most basic form, comprises a string or rod with a weight at the end, known as the bob, that swings back and forth under the influence of gravity. The swinging motion of a pendulum is a beautiful demonstration of several physics principles. It involves concepts such as potential and kinetic energy, oscillations, and the force of gravity. But don't worry if these terms sound like a foreign language. We'll break them down to their simplest forms. First, consider potential and kinetic energy. When the pendulum bob is at the highest point of its swing, it possesses maximum potential energy due to its height. But, as it begins to fall, this potential energy starts to convert into kinetic energy, the energy of motion. At the lowest point of its swing, the pendulum has maximum kinetic energy and minimum potential energy. This energy transformation continues back and forth, just like the pendulum bob swing. Now think about oscillations. An oscillation is simply a back and forth movement. In a pendulum, each back and forth swing is one complete oscillation. The time it takes to complete one oscillation is known as the period of the pendulum. Remarkably, the period of a simple pendulum depends only on the length of the string and the acceleration due to gravity. It does not depend on the weight of the bob or the amplitude of the swing. This is a unique characteristic of pendulums which makes them incredibly useful in devices like clocks and metronomes. Finally, we have the force of gravity. Gravity is the force that pulls the pendulum bob downwards. But as the bob is connected to the string, it can't fall straight down. Instead, it swings along the arc of a circle. It's this combination of gravity and the tension in the string that creates the pendulum's rhythmic swing. So, to summarize, the physics of pendulums involve the interplay of potential and kinetic energy, oscillations, and the force of gravity. The pendulum's rhythmic swing is a result of the constant transformation of potential energy into kinetic energy and vice versa. Its period, or the time it takes for one complete swing, depends only on the length of the string and the force of gravity, not on the weight of the bob or the amplitude of the swing. And it's the combination of gravity and the tension in the string that gives the pendulum its unique swinging motion. In the grand scheme of things, understanding the physics of pendulums offers a window into the fundamental principles that govern our world. It's a simple yet powerful demonstration of how energy transforms and how forces interact. So the next time you see a pendulum swing, take a moment to appreciate the beautiful dance of physics at play.